Hello, rock stars, and welcome to your Sedimentary Rock Identification Lab. Your job is to complete this table as you've done before with the texture, grain size, composition, and rock name. We're going to use number 3 as an example, and you have 12 different rocks to look at. To start, open this link. Command click or control click will open this in a new tab, which is always handy, so you don't have to switch back and forth. By the way, the screen for you looks different. The video I'm recording is what's going right here. Weird time-lapse thing in my brain. It hurts. Okay, as you know, sedimentary rocks are composed, well, of sediment. God, geology is so hard. And you usually get sediments where things are stacking up, which means in low places where water or wind has deposited those. You're going to be looking at texture, clastic rocks, chemical rocks, biologic rocks. Let's go over those. Texture. If it's clastic, it means it's made of, well, clasts. God, there we go again. Clasts in sedimentary rocks are broken into clay. Super fine. You have played with Play-Doh as a kid. That's essentially clay with some oil and water stuck in there and some emulsifiers. Silt, a little bit larger than clay. Sand, you know what it is. It tells you it's 1/16 to 2 millimeters in size. And gravel, what you do not want to fall on if you're running. Anything larger than 2 millimeters. Chemical rocks. Chemical rocks are caused by either precipitation, two materials going into water, combining to make a non-soluble compound and then settling to the bottom, or through evaporation of the water, leaving something behind. If you've ever left salt water on your counter all night, come back in the morning to see crystals there, you just formed a chemical sedimentary rock. There are 4 chemical rocks in this lab. They are quartz, halite, gypsum, and calcite. Yes, I know those are also minerals, but they can form as rocks. The neat thing about calcite, it reacts with hydrochloric acid. Halite is cool because, well, those of you who have taken chemistry know what halides are. They are salts. I used to live in Athens, and the word for salt was alati, which is very close to this. Halite is rock salt. If you've ever made ice cream the old-fashioned way, you used halite, rock salt. Or if you have a water softener, you have that. And gypsum, it's soft. You can scratch it with your fingernail. It's what makes up wallboard. Biologic rocks form from compacted shells, fossils, or very small little pieces of diatoms that are in the ocean. Here's your identification chart: texture, grain size, composition, and rock name. Let's start. Let's go through these really quickly. Again, you can look at a close-up image. This one is what I would call massive. Weird. Number 2. Wow. Looks like a granola bar. You probably know what that is if you've been to Florida. Number 3. Number 4. I've got to admit, it's easier to do this in the real classroom, but this is the best we can do right now, so we'll work with it. Just be glad this is out there. Imagine if you had only a worksheet with which to do this. Looks like a bunch of stuff thrown together. 9. Weird. 10. I like this one. And number 12. Whoa. Okay, let's do number 3 as a demonstration. There's nothing bigger we can look at. Let's see if hydrochloric acid reacts with it. No, it doesn't react to hydrochloric acid, so we know that it's not anything having to do with calcite. So it means it's not limestone for sure. It's not limestone for sure. Didn't I just say that? It's not chalk, and it's not calcite, and it's not fossiliferous limestone or fossiliferous dolostone. I love that word, fossiliferous. Let's do the hardness test. Oh, okay. Okay, can't scratch it with a 1. Can't scratch it with a 2. You can see somebody scratched it here. So it's got to be about a 2.5, maybe a 2 to 3, somewhere around the hardness of your fingernail. So we know that it's not a quartz material. Okay, next. Would you say it's formed from biologic stuff? Does it look like it's made of living things? I don't see shells, but it could be made of really fine stuff. But I doubt it. If it were, it would have reacted with acid. And when we tested it with acid, it didn't react. Is it chemical or clastic? Does it look like it's made of other pieces of rock? Looks like it's just evaporated or precipitated out of water. So I'm going to take this one, which means there's no grain size. It's too soft to be silica. It didn't react with acid, so it can't be dolostone or calcite. So it has to be either halite or gypsum. There's no taste test here, but does this look like rock salt to you? It might be, but I don't think so. So I'm going to go with gypsum, which makes it rock gypsum. Let's see how we did. We got everything correctly. So we will stick texture, grain size, composition, and rock type into those fields for number 3 and submit. It's that easy. Have a good time. That's all.